Hey everyone, my name is Nilis and I'm a product manager at Unchained Labs. I will be your moderator and thank you for joining us today. We will have a Q&A session at the end of the demo. To ask questions, all you have to do is click on Q&A in the Zoom navigation bar at the top or bottom of your screen and type your question. We will get to as many of them as we can. And now I'd like to introduce Chie, our field application scientist. Today, Chie will tell you all about nucleic acid quantification on Lunatic and walk you through a quick demo of our amazing instrument. Now I'll hand it over to Chie.
Thanks, Nellis, for that introduction. As Nellis just introduced, my name is Chie, and I'm here to show you today about a Big Lunatic, and I'm going to run the Big Lunatic with you. Specifically, I'm going to run some DNA samples and just show you how you can run the DNA samples on the Big Lunatic. The Big Lunatic is essentially a UV-vis spectrophotometer, but it has excellent precision and accuracy with just 2 microliters of samples because of this awesome consumable we have. And so you can actually run up to 96 samples using one of these plates in about as little as 6 minutes. So first things first, let me show you how to load these plates. So why don't you walk over with me to my bench space? Let's go over. So this is the Big Lunatic plate, kind of a more zoomed in picture of it. It's the same spacing as a 96 well plate. So you can see right here, these are essentially the areas that you are going to load your sample. So these little circles right here. As I said, I have my pipetter set to 2 microliters. So with just 2 microliters, we're going to go ahead and load these samples right here. If you take a little closer look at individual wells, so this is like kind of one little well, there are little microfluidic channels inside of here. So when you load the 2 microliters, it's actually going to get drawn into these little squiggly parts, which is our reservoir chamber. And for as long as like 2 hours, you see little to no evaporation at all. So that's actually great since you're loading such small volumes. You want to make sure that you don't change the concentration due to evaporation. And then these little diamonds in the middle right here is essentially where your samples are going to be read. You can think of that as your little mini cuvettes. So I have some fluorescein dye with me just to kind of demonstrate to help you visualize exactly how the samples are getting drawn into our plates. So here's some fluorescein dye, 2 microliters. I'm going to go in this A1 position. I just pipette out. I don't blow out. And you can see it getting drawn in this little squiggly part. It's super cute. It's actually quite satisfying. And then really nice thing about fluorescein, so I think it's pretty nice, and you can kind of see the actual dye itself because it's pretty concentrated. But fluorescein also, with a black light, you can kind of see it shining. So you can kind of see where that goes. So when you load the plates themselves, they do just stay in that squiggly part like that, and then inside the instrument, they get filled into the cuvette. All right, so let me actually take this away and load some DNA samples. So I have some DNA samples with me right now, different concentrations and TE buffer, and I have some DNA samples also that may be a little less pure. So let me go ahead and load those with you really quickly. So I have some TE buffer with me, so I'm going to load my blanks. And to really show off the precision of this instrument, I'm going to load them all in duplicates. Now, the blanks I'm also going to load in duplicates, but you don't have to run those in duplicates, by the way. But all my samples, again, I'm going to go ahead and load those in duplicates. Again, if you have a multi-channel pipetter, because it is the same spacing as a 96 well plate, you can absolutely load it using a multi-channel pipetter too. So today, since I don't have that many samples, I'm just going to single channel pipette them. So these guys are different concentrations of double-stranded DNA that I have right here. Now, as I'm loading, I'm just going to quickly tell you a little bit more about the plates. So I have with me this, what we call a high lunatic plate. Now, if you look really closely in the little cuvettes, there's actually 2 little cuvettes inside of there, 2 little diamonds, which are measuring wells. So for that, what that means is it's a 0.1 millimeter path length and a 0.7 millimeter path length. And so because of that really small path length, the 0.1 millimeter path length, it allows you to read up to really high concentration. So you can go as high as 275 OD, assuming a 10 millimeter path length. So it's calculating it like it's a 10 millimeter path length. We have a regular Lunatic plate also, which is just has one little cuvette, and that one is for our users that maybe don't need to go as high of a concentration. So that's essentially what we have. All right, we're all loaded and ready to go. So I'm going to go ahead and take this plate and walk over back to the instrument, and let me show you the software and how to load the plate itself. So let's walk on over. All right. So I'm going to go ahead and show you the software. So there's two pieces of software that comes with the instrument. We have the Lunatic client software and the analysis software. So the client software is what's going to run the instrument. So that's what I'm sharing right now. So this is the main screen of our Lunatic software. And I'm going to go ahead and click on nucleic acids because I'm running double-stranded DNA today. Let me click on that nucleic acids tab. And essentially, I'm going to do this A260 classic application specifically for double-stranded DNA. Now, the Lunatic can it measures the full absorbance spectrum between 230 nanometers and all the way to 750 nanometers. So you're getting that full absorbance spectrum, by the way. But we're just getting that absorbance at 260 nanometers and then taking that with a concentration factor to calculate the concentration of DNA in the samples I just loaded with you. Just click next. So again, the two different plate types that we have, I'm going to click on the high Lunatic plate because that is the plate type I have with me. And you can enter the experiment name, whatever experiment name that you have. And then click next. The next part is going to be where you tell the instrument where your samples are. So you can see visually right now, it's the same setup as the plate itself. So I can click on the blanks. So right here, I have blanks in A, B, and so on. And then I have samples. It's a click and drag. It's super nice, so user-friendly software. I can erase that too. Now, the other nice thing is if you have 96 samples, you probably don't want to be clicking around all the time. So you can also import an Excel file. So I'm going to actually show you how to do that. I actually prepared an Excel sheet. So right here, there's an import template button. So the actual template itself that you have to use to import an Excel file looks something like that. Pretty straightforward. B for blanks, S for samples on this very left-hand corner. You just enter your sample information, and that all is going to get imported for you when you click on the import button in the client software. So import sample template, click on that folder of the sample that I have, and voila, nice and easy. It's all in there. So let me just click on import, and it just imported all my samples for me. Next button is next. This is where you get to group your samples. So I actually have a set of samples that are pretty pure, and I have a set of samples that are not so pure. So the first column are my pure samples. So I kind of separated them out in different groups. You can click on next. And then because I imported an Excel sheet, you can see that all my sample information has already been imported. If you didn't use an Excel sheet at this page also, you can actually type it in. Just double click and type in the names. We're going to click one more time. And then the next thing that you're going to do is just click on next. So it's just making sure that everything looks good. You're happy with it. Click next. And all right, so as you can see, the tray automatically opened. So I'm going to go ahead and load the plate that I just loaded with you guys right now. The little notched out corner goes right here on one side. It's nice and kind of a loose fit. So you just pop it in there. Right, once it's popped in there, you just have to close and push start. So go ahead and push start, and the tray will close automatically. As the measurements are being made, it'll just go and read the samples one well at a time. It'll draw in so it measures the empty cuvette, draws in the sample, and then measures the filled cuvette also. All right, so while these samples are running, actually, let me stop sharing my screen really quickly. And Nellis, since this is going to take a few minutes, are there any questions that have already come in? It's been not that long, but.
Oh, gee, that was a very quick experiment setup.
That's kind of the lunatic for you. It's really fast to set up an experiment. And that was with me
Um,
loading 16 samples, by the way.
so actually, we already have some questions, some great
All
questions
right.
for everyone that still wants to submit some. You can do it throughout the session in that Q&A section on your Zoom navigation bar. Chia, your first question. Could you give a bit more clarification on the measurement range for double-stranded DNA?
Sure, that's actually a good question because I just said the OD range, I think, right? So I'm going to kind of translate it into both languages because I know just measuring in absorbance isn't always simple to know what that means in concentration. So OD range-wise, just limits and kind of ranges, I would say. The lower limit for our lunatic plates are about 0.03 OD, again, assuming a 10 millimeter path length. Now, if you remember, we have two different plate types. So the regular lunatic plate, the upper limit for that one is about 40 OD. That translates to about 2,000 nanograms per microliter on the upper limit for double-stranded DNA. The lower limit is about 1.5 nanograms per microliters for that, what that OD range means. Now for the high lunatic plate, which I have with me right now, that lower range is the same. It's about 1.5 nanograms per microliter. The upper range is like 13,750 nanograms per microliter, just based on the extinction coefficient we're using or the concentration factor we're using. So that's a pretty high. It's pretty high.
Okay, great. Second question while we're waiting on the system. Can I use the rest of the plate immediately, or do you need to run the full plate at a time, ideally?
Yeah, so you don't have to run the full plate all the time. So actually, before I say anything else, so the plate is actually ejected, so I'm going to pop this out really quickly, and I'll explain why. But to answer your question, so you don't have to use this full plate every time. So like right now, I only used 16 wells. I can use the other positions later. So I usually just mark the wells that I used for the next user and go ahead and use the other positions. In the software, as you saw, you're able to set where the samples are, and the instrument will only read those positions. Now, while I'm talking, do you guys see that the tray just went away? So that's the nice thing about the Lunatic also, by the way, that the tray does come out. If you walked away or if you're busy like I am right now, you might be worried that someone's gonna run into it, right? After 30 seconds, the tray just puts itself away. It's saying, okay, no one's paying attention to me. I'm gonna put my tray away, make sure no one runs into it, so.
Okay, I'll let you do the rest of the analysis and I'll see you soon.
Thanks, Nellis. All right, so like I said, there's two pieces of software that come with the instrument. So analysis and client, essentially. So it always asks you very politely if you would like to look at the results. So that's very nice of it to ask. So let's take a look at the analysis software together. All right. So the first thing that you're going to see when you open up the analysis software is the overview picture. So with the overview picture, again, I'm a pretty visual person, so this is really helpful for me because I remember what positions I loaded things. So in this case, the first column, so you see my buffers that I loaded and the NA samples, and then you see the protein samples that I loaded. Same thing with column 2 also. So it's just the exact plate format and the plate layout. If you click on the actual wells themselves, so they have the concentrations right below the little pictures that you can see, but you can click on that and it takes you to the detailed view. Now you can also go to that detailed view from the detailed tab up here, so you can absolutely click on that also. So just to kind of show off our replicates, so you can kind of see how reproducible that is. So this is C1 and D1. I'm overlaying that. So it just looks like one line, basically. That amazing precision really comes from the consumables where we have this fixed path length cuvettes. So it's a fixed path length every time. If you take a look at the different concentrations I loaded in my first column, you can see my approximately 1,000 nanograms sample, and then when I diluted them down. So just kind of showing you that range. Whenever you look at the data, so when you look at them individually, they always give you the concentration, nice and simple, the absorbance at 260, and then the ratios that you can see. So just based on these ratios, you might say, okay, these look pretty nice. They're pretty pure samples. That looks great. But what if you have a sample like this? So I told you I have a couple of samples in there that may not be so pure. So in this one, we actually have a little bit of protein in there. So there's some BSA in there actually. But if I looked at this, you can look at the ratio and you'll say, okay, I know that the sample isn't pure. But you're going to have to just rely on the concentration it's given right here, just the absorbance concentration here. So what's really nice about the Lunatic is we actually have some deconvolution software that's going to help you to deconvolute and separate out the absorbance with 260. And if there's some protein in there, it'll kind of, separate that and deconvolute it out. Well, you might say, do I have to run another experiment then to do this? The answer is no. It's really nice because it can just do a recalculation for you. So on this right-hand side, there's something called select application. I'm going to click on that. And what that lets me do is recalculate this data set. So without rerunning the experiment again, rerun it as something else. Now this deconvolution software that I just told you about is this unmixed category. And specifically, I know this application right here is going to look for some protein and EDTA and certain impurities. Now there's a set number, I guess, number or things of impurities that it's going to look for. So if you take a look here in the explanation in the bottom part, it says proteins, thiocyanates, salts, and so on. So there's a specific thing that it's going to be looking for. I just recalculate that and just click on recalculate, and you can see exactly what I mean. So it's right here, the purple spectrum is my nucleic acid. The blue is the impurities that it found, and it kind of helps you to get a better estimate or better concentration read for your DNA, for example. Same idea with if I had excess EDTA, it did affect that absorbance a little bit, so it helps you to get a more accurate measurement of the amount of DNA that's in there. So that's essentially what this can be used for. A couple of other neat features is really easy to use software. You can recalculate this. Let's say I need to edit the sample names. I was in a rush last night. I had to set up my experiment. I'm going to edit my sample names because I didn't have time to do that yesterday. You can always edit the sample names at this point and apply them. You can also edit experiments. So I don't know if you've ever done this before, but I was in a rush and I just set up my experiment and I realized that the well that I loaded as a blank wasn't actually a blank. You can actually change that. So you can just say, oh, no, these were actually samples, and recalculate the data set based on that. Same with the sample grouping. If you grouped it not quite right, then you can recalculate that and change it and then remeasure those samples. Reanalyze that sample. So again, you don't have to remeasure it. Even though it's just 2 microliters of sample, we want to make sure that we can save any sample and also your time to make sure that you can get everything done efficiently. So, all right, did I forget anything, Nellis? I think if that's it, then that's pretty much how you run a Lunatic experiment. So that was including the setup, me loading samples, setting up an experiment, running 16, well, actually less than 16 samples, including the blanks, but 16 wells, and analyzing it together. So that was that. All right, Nels, do we have any other questions that I can answer?
Oh, thanks, Jie. That is extreme. In like 15 minutes, you did all that. It's unbelievable. So thank you for that great demo. You showed us how simple and quick an experiment can be set up with no hassle on sample prep, and how straightforward the analysis is with additional in-depth on all our unique features. We do have some more questions, so if you're ready, if you're up for it.
Yes. Bring it on.
First one would be on sample loading. Can a liquid handler load the plate?
Yes, so the plates are SBS formatted plates. So as long as your liquid handler can load about 2 microliters of samples, essentially. As long as that can happen, then you can absolutely load the plates using a liquid handler. Now, I don't know if that is a robotic system, so we have users that are kind of integrating it into their workflow to various degrees. So we have some users that are just loading the plates using a liquid handler in an automation system. And then we also have people that are fully integrating the Lunatic system. So using like an API, for example, and using the Lunatic, that it is able to be, it is automation compatible.
Okay, great. Second question would be, now you run all those samples, do people actually need like a standard curve or anything, or is this just popping out?
We are using a certain concentration factor. So it's basically Beer's law. We're getting the absorbance of your samples, absorbance at 260, essentially, using a concentration factor and calculating concentration from there. So extinction coefficient and calculating concentration from there. So no, you do not need a standard curve. Same idea with protein users. So if we have any protein users out there, if you have your extinction coefficient, then again, same idea, absorbance spectrum at absorbance at 280 nanometers, use that extinction coefficient and you get the concentration. So yeah, so you don't need to. Now, if you don't know your extinction coefficients, you need to use a standard curve. For the protein users, you can use those classic protein standard curve options also. It is available to you as an option.
Great. Next question. You quickly mentioned unmixed. So what are some of the contaminants that unmixed can identify in people's samples?
Sure. So the one that I ran today, I think there were like cyanates, EDTA, detergents, and protein were some of the things that were listed. They're kind of based off of very common kits that a lot of people use, some impurities that come from that. So again, it is a set list of samples. They're always available to you in that description button too. So you can just click on it and see exactly what it's going to be looking for.
Great. They keep on popping in, so let's keep on going. Can people run experiments with different buffers on one plate and still able to blank somehow?
Yes, I'm glad someone asked that. That is one of the many things that I love about this instrument, because when you're running 96 samples, you might not have the same buffer for all of them in certain situations. The answer is yes. In that sample grouping that I showed you earlier when we were setting up the experiment, you can essentially just say these buffers need to be blanked from these samples, these buffers get blanked with these samples. So that is kind of a way that you can use that sample grouping. So yes, absolutely. You can do that, and I love it.
Okay. If you wouldn't run a full plate, if you already used some samples or some wells, so for marking those used wells, is there colors that should be avoided to mark it or anything like that?
Yeah, so if you, actually let me reach over real quick. I don't know if you can see my plate. So you can kind of see through this part where you can see my hand. So that's the part where your measuring cuvettes are. So that's kind of where your measuring samples are. So as long as you don't mark that area, so as long as you mark the sides, you're good. There's nothing you have to worry about. It's not going to interfere with that as long as it doesn't go into the well, which again, with the microfluidic channels, it's very unlikely for that to happen. So as long as you don't mark right where my fingers are right now, you're good.
Exactly. Another great question is this software 21 CFR Part 11 compatible?
Yes, it is. With the purchase of an additional license, you can absolutely, it is compatible, yes.
Okay. There's a question more specific on some data you showed. It was marked at 1,000 nanograms per microliter, but actually when we looked at it, it was 1,090-ish. Can you just explain how that comes?
So that was actually just a prep thing. So we were using just mixing like CNA. We were kind of going for approximately 1,000, and then the Lunatic actually told me that it was a little bit more than 1,000. So if anything, it told me that my prep was a little bit higher. So it wasn't a standard or anything that I was running. It was more of a prep that I did.
Okay, great. Can the system only handle the impurities listed in the software, or are there other options? Or yeah, that's the question.
Okay, other options. So for the unmixed app specifically, you can't add other impurities for it to unmix the way that I showed you today. So, deconvoluting and, separating out the spectra like that. So the answer to that is no. But there is an option that you can do where, let's say you want to take certain ratios. So I don't know if there's ever a case where you want to take a certain ratio of not just 260, 230, 260, 280, but other things like that from the regular raw absorbance. You can kind of create your own outputs in that sense of ratios. So it's not a deconvolution, but you can kind of do those outputs. And that is what we call our homebrew application. You as a user, so if you're doing dyes or something else attached to them, then you can do those ratios also. There's also an application if you have a dye conjugate, dye mixture, you can also look at the dye concentrations too. So a couple of
Yes,
options.
indeed. We have a lot of different applications and a lot of different unmixed options that all have their own specific impurities. Indeed.
Yes.
How do you know, this is more a practical thing, but how would you know if a sample is too viscous, or is that possible, which theoretically, of course, and how would you know if you need to dilute it, or if something didn't work out or something like that?
That's a good question. So for viscosity-wise, just purely viscosity-wise with these microfluidic channels, of course, there's a limit, an upper limit to that, and it's about 40 centipoise. Now, what does that mean? Well, the fact that you can read an extremely high concentration of DNA should give you an idea that it's a pretty high, especially for nucleic acids. I think it's pretty high. But how would you be able to tell if it was indeed too viscous? Is that the instrument wouldn't be able to pull the solution into the cuvette. And in that case, you'll actually see just like an X mark saying like the measurements weren't able to fill the cuvettes kind of thing. So you would be able to tell in the software. And you would see that in that overview picture that I showed you in the beginning in the analysis software.
Okay, great. That's all the questions we have time for. So thank you for that great demo. Thank you for that great presentation. And I want to thank everyone who joined us live as well. If you would like to have a deeper conversation with our team, please don't hesitate to get in touch with us. We would love to connect with you. And thank you again for attending our live demo. And I hope everyone has a great rest of their day.